Greetings. My name is David Bray. I'm Executive Director for the People-Centered Internet Coalition, and I'm here with a fellow colleague and friend and also fellow Eisenhower Fellow, Frederick. Frederick, could you tell a little bit about yourself and what you do?
Well, hello, David. It's good to be here. So I'm Dr Bruhn. I'm the Managing Director of an IT company doing a lot of AI in Sweden called Unibap. And I have a background as a research professor in robotics and avionics. I previously had a satellite company, and I did part of my PhD work at the NASA's Jet Propulsion Lab in Pasadena. So I've been fortunate to work in space, in military programs, in industrial contexts, and applying machine learning on those different areas.
Excellent. And so what we're hoping to do here as fellow Eisenhower Fellows, and as well as people really interested as to what's actually really happening with machine learning and AI, the real tangible endeavors as opposed to the things that are far out there that may occur but are still too far out to actually sort of be seen, is to have conversations about what's really happening with machine learning and AI today and how that impacts organizations, how that impacts teams, societies, governance. We're really going to try and do this as a monthly series of both videos and blog posts that go along with that. And to sort of launch it, when we were talking a little bit earlier about what you do, you were talking about there's multiple layers to AI and how one needs to think about a multiple layer approach to it. So I was wondering if you could share a little bit more about that, Frederick, and how you do that at your company.
Yeah, absolutely. And there are many different takes on this, of course, but if we try to look at an industrial context, typically you would have a cloud-connected connectivity, you would have cloud services. However, cloud services is susceptible to cybersecurity issues and reliability issues, things like that. So there is a very clear trend that a lot of the machine learning systems and also the manufacturing execution systems for factories are being moved on-premise. And on-premise could also be called fog computing, so it's an isolated system in a factory. This has multiple applications. One is that you have an increased reliability because you only have dependencies within your factory, but it also gives benefits in terms of cybersecurity because you're disconnected. So basically, in terms of cybersecurity, it's only internal threats that you have to deal with. But this comes with a price, of course, because you lose the connectivity. So unless you have your own global communication infrastructure, you won't have access to the big cloud. And then, of course, you can try to isolate your different networks and try to mitigate this. But what we're also seeing in terms of reliability is that a lot of the AI and machine learning is being moved all the way out to the edge. In this case, all the way out to the actual manufacturing lines, where human operators are replaced or enhanced with AI-based operators, or what we call virtual operators. So for instance, things like quality assurance or flexible automation, where industrial robots cooperate with humans, are becoming more and more common. And this is actually happening right now. So we are actually in the midst of seeing the smart factories on a big scale. And that changes society in a major way as well, because one of the big impacts is that the Western world can keep manufacturing onshore, because it doesn't really matter where you put the robots, they have the same cost wherever they are in the world. It's basically the price of electricity that differs. And that has a major impact. There is obviously a shift in labor, but it's also a way of having domestic production like we used to have as well. And it's, as I said, happening now.
Right, and I think that's fascinating to hear you talk about how we can expect it to actually, in some respects, for the Western world, it's actually a way that jobs that may have been previously offshored come back to those countries, because it is this idea of robots working alongside humans. Now, I was wondering if you could tell me a little bit more about those sensors that are happening on the edge. Are they visual sensors? Are there other types of sensors, tactile? I mean, what are they looking for, and about how long are they going to capture that when they...
There are a whole suite of sensors being developed, but for the sake of argument, let's look at what we do, and we try to do vision-based systems to mimic humans. And typically we have a small vision system. It's about the size of a human hand. It has the same 70 millimeter or 7 centimeter between the eyes like the average human. And whatever a human can do in a factory, we try to mimic with machine learning. So whether it's quality assurance inspections, or if it's in robot movements or things like that, we can do exactly the same. And as you can see from videos that we attach to this as well, you can see examples of this, how it works. So basically, we teach the system to understand, like a human operator, what it means to do assembly or welding or drilling or grinding, whatever is needed for the manufacturing site. And you try to do that as close to the robot as possible, because you really want the robot to be just like a human body, you could say. And to do that, it requires you to move your AI algorithms all the way out to the device itself. And that also gives a tremendous benefit, because you know that even if you lose connectivity within your factory or to the cloud, you can still have your manufacturing. Although you may not have all the features which you have if you have the connectivity, but you guarantee the operation of the factory. And if you have cloud connectivity, maybe the factory can be more efficient, or it can go faster, or things like that. And this is a big trend shift, because a lot of the concepts for smart factories up to now has been purely based on 5G connectivity to the cloud. It's hyper robust, it will never go down, it will always be there. And a quick analysis shows that you will not always have that cloud connectivity. And that's rapidly becoming a very clear sign for big corporations that, oops, yes, this is great technology, but it's not bulletproof. So you actually need to distribute your learning system, your reasoning systems on a multi-tier level.
And I think that's very well said, and I liked how you put it about 5G. I often feel like 5G is a tool in search of problems to be solved, as opposed to the other way around. And I'm sure it maybe will eventually find some interesting applications. But as you said, even if you had that connectivity, there's still things that go wrong in a massive cloud environment. If you really need to get that sort of 5-9 uptime, as you said, you really need to have things at the edge and in your local fog. I also liked how you put it that the cloud is really about making things possibly go faster, but the reliability is happening in the fog and on-prem as a way to sort of balance that. And so I'd be interested in your thoughts about what data do you see going from the edge device to the fog, and what data do you see going from the fog to the cloud? Can you give us some sort of like tangible examples about what data is being moved back and forth between those layers?
Absolutely. And in order to discuss that, we should go back also and look at connectivity reliability. Today, you see a lot of DDoS attacks. You are syncing big server farms for Facebook with these kinds of attacks. So even if you have an internet connection, it's super easy for someone to make sure that that connection goes slow. And if it's slow, you can only send a small amount of data through. So basically, the way we are reasoning is that you generate a lot of data at the sensor, and you try to interpret and reason within that data in the edge. And then when you have refined the data, you have a better understanding at the sensor level, you send some of that data. So the understanding at that level, you send to the fog. And in the fog, on-premise, you reason with other sensors from your factory, and you try to create a larger understanding on the factory level. And that data is in turn possible to send to the cloud to reason on a global scale. So if you generate maybe 100 gigabits per second at sensor level, you may only transfer maybe 10 megabytes or so per second to the cloud for the reasoning. And then you can always say, well, I want to send my 100 gigabits per second to the cloud for image storage. But it also seems to be a quite clear trend that you don't want to store all the data. You want to store the relevant data that brings customer value. And that's typically, if it's imagery, it's typically images which are connected to events. So either it's a good event or a bad event, or it's something in between, but you really don't want to have data that is not connected to any event, because that's not that useful unless you have a very specific application for it. And this is rather interesting. So whether you have a 5G or an LTE or a physical fiber link, the network infrastructure in terms of routers and things like that is sensitive to a lot of different attacks. So even if you don't want to actually hijack the data or steal the data, you can still cause major interruptions to business models that are fully cloud-based.
I think that's very well said, and I've had experiences in the past where it wasn't the network layer, it wasn't the transport layer, which most people think about when you talk about like denial of resources, denial of service. It was actually at the application layer, which it's interesting because even, this was a few years ago, but even then, people weren't looking at layer 7, and when you referred to it, people didn't understand what that meant. But what you hit the nail on is, even if you don't want to sort of either hijack the data, steal the data, or destroy the data, if you just want to slow the data flow to and from the application, it's not enough just to protect your layers 3 and 4 with the network and the transport. You really got to think about the application, and what you're saying is this model of use the cloud when it makes sense, and then that may make sense in a global area, or maybe you're just a small enough organization that you can't afford to do things on-premise for long. But if you're really doing it where you need to have the upstream necessary, it's thinking about how you do that at the edge and at the fog, because that gives you more reliability as a way of doing the AI.
Absolutely, and there is another interesting aspects to this as well. If you look at the whole discussion around time-sensitive networks, that's the new holy grail that will make the smart factory beautiful. It will even be even more reliable than 5G, etc. So it's a beautiful way of having a real-time quality of service guaranteed Ethernet system, basically. So I'm involved in a lot of TSN research at the university, and what's interesting is that with all these guarantees, we had a major breakdown in one of the big demos, and we were searching for 2 days why we had this error, because the data was supposed to be guaranteed. So looking, searching, we found the solution after a while, because the IT guy at the university disconnected the wrong wire. So he moved a Cat6 cable and put it in a different switch.
Oh.
So even though the TSN network was working, it guaranteed quality of service, it wasn't better than the IT technician who actually moved a cable, because he needed a cable, so he took one.
Right. Yeah, exactly. It reminds me of the phrase, if you want a perfect system, make sure no human being touches it. That's just...
Absolutely. And that's also why it's super important that if you have an automated factory where you have cobots, you have collaborative robots, you have automated quality control, you have process feedback loops, you absolutely have to bring the AI all the way out to the edge and basically only have a requirement on power. And that power could potentially even be a battery backup locally. But if you have that and you have full control of all the wires within that system, you know that no one can touch that unless they break these security protocol. And that gives you a credibility that you will deliver 24/7 year round.
That's great. So I guess a question that I have for you as we wrap up, so you talked about bringing the AI, the robot to the edge. In the factory that you see with your company, have you found there's interesting behaviors that emerge where the AI is interacting with the human? Are there things that you either find surprising, or behaviors that emerge with humans interacting with machine learning?
We haven't seen any of those effects, but effects that we have seen is that when machine learning meets old companies that's been manufacturing parts for industry for 100, maybe 200 years in certain cases, at least here in Sweden, those companies are not very well prepared for this. So the operator who meets machine learning, it's a new tool. It's, wow, this is a new friend. And after a few weeks, this friend of mine is actually as good or better than I am. And that's shocking to people that it actually works. That's a big, ooh, wow, it works. And the other one is that the tools are becoming readily available. So the interaction with an AI is quite simple. You can do that through a cell phone or through a pad or laptop. You can click on the screen. You can say that this is correct, this is wrong. I want you to approve this. I want you to disapprove that. And the reason I want you to do that is because my gut feeling is telling me that this is correct and that is not correct. So you're actually capturing the tacit knowledge that these guys have. The operators who's been doing this for 15, 20, 25 years, they bring a lot of gut feeling or tacit knowledge with them that they cannot possibly write down or tell someone else. But they interact with the system and they say that this is right because I think it's right, and the system actually adapts and learns that. And that's a very powerful message, both to convey and also for people to experience that, hey, this machine doesn't do what I told it to do by writing something. It actually does what my gut feeling does. And that's a very big, an interesting change.
I think that's absolutely key because as you said, so much of our knowledge is tacit knowledge that we cannot necessarily write down or make explicit. It's in our head, it's based on experiences, it's a gut call. And in the past, people have had a hard time sort of putting that in writing when they're trying to sort of put forward why they think something's happening or why something's occurring. But as you said, the machine, through its interaction with you over a daily basis, can begin to key in it, and there's actually a transfer of tacit knowledge without the person recognizing they've actually made it explicit, simply between the behaviors the human does with the machine. And so I think that's going to be a great thing for us to talk about next month. But I really appreciate this conversation. This has been a great start to what I hope to be is a monthly series that we do before I come and actually visit you in Sweden. I want to again give a shout out to Eisenhower Fellows, which we both were. World.org. It's a great organization, both to bring people to the United States, but also to have people from the United States travel abroad. Also want to give a shout out real quick to Ray Wong and his team at Constellation Research. They're doing great work looking at these trends that are happening in AI. Our hope is actually that we can bring them into the conversation in the future, because I think it again is grounding the conversation of machine learning and AI, so it's actually what's really happening today, so then it can inform us as to how we go forward in a more people-centered way going forward. So Frederick, again, you get the last word. Thank you for joining me, and any last words you get to say.
Thank you, David. And I'm very happy that we have this opportunity to do international collaboration, discuss AI. What is it? It's not strange, it's science, and we need to spread that word. But I also think that we need to inform people that this is happening now. And the politicians, as well as the educational system, have to realize that.
Well said.
So thank you very much.
Thank you, Frederick, and look forward to when we join this conversation next week or next month. Thanks again, all.
Thank you.